We're going to take a look at equilibrium today. I'm going to give you guys a brief overview of what the reaction is going to look like. And then we're going to go ahead and set up the equilibrium and manipulate it in whichever way that we can. So this equilibrium reaction is very similar to the reaction that happens when you breathe in and oxygen attaches to the hemoglobin in your blood, and you breathe out and it's replaced by carbon dioxide. The hemoglobin in your blood contains 4 protein chains into a large protein, and in the center of each of these chains is an iron 3 ion. So we have this ion that is Fe3+, and that's what's found in the center of your hemoglobin protein. There's 4 of them. Iron 3 is very positively charged, but oxygen gas is quite electronegative. So there's an attraction between the oxygen and the iron 3. So this will actually come in and it'll stick to the iron. When a chemical sticks to an ion, we call it a complex ion. It doesn't form a crystal. It just takes the ion that we have here and attaches pieces to it. And these pieces are called ligands. Now, when oxygen is attached to the iron in your lungs, it's then carried through the blood on the hemoglobin to the cells that need the oxygen, and after the oxygen is taken, it's replaced by CO2, and they stick to the hemoglobin. So we take this one off and we put this one on. And if we want this reaction to happen, because it's at equilibrium, each one moving on and off as it's needed, if we flood the blood with CO2, the CO2 attaches and the oxygen releases. If we flood the blood like we do in the lungs with O2, the O2 attaches and the CO2 releases. Okay, in our reaction, we're not going to use oxygen gas. We're going to use an ion that's similar, but is not a gas. It stays dissolved in the water, and for us, it's easier to manipulate. So we're going to have our iron 3+, and we're going to use a ion called thiocyanate. We have an S bonded to a C bonded to a nitrogen. And just like the carbon dioxide up here, we have a very similar structure. And the nitrogen here is very electronegative. So the nitrogen will stick to the iron. So we're gonna have this thiocyanate ion attach to the iron with the electronegative. There's a partial negative side stuck to our positive iron. And we get a complex ion that's called Fe SCN 2+. So the 1 minus, this has a 1 minus on it. The 1 minus here plus the 3+ here gives us an overall charge of 2+. So we're going to create this complex ion, and now we're going to try to change it. We're going to try to force this guy off. We're going to try to force more of them into the iron. Let's take a look at the chemical reaction that describes that process of the thiocyanate attaching. We have Fe3+ aqueous attaching to SCN- aqueous, and we get FeSCN2+ aqueous. It's a complex ion because it's still dissolved in the water. It's not a crystal. It's combined with the 2 ions. And this is at equilibrium. It goes forward and backward. Now the Fe3+ is this color. So it's a light orange. The thiocyanate is this color. It's clear. And when we form the 2 together, you'll notice it'll turn blood red. So as we manipulate this equilibrium, we should be able to move back and forth between the 2 colors. And that's the experiment we're going to run.